All right, let's get started on learning a little bit about grid games. This is just going to be one introduction to a way to do grid games because a lot of students like to make this kind of game. You're going to see a couple concepts here, and the most noticeable one is we're not going to use the speed variable built into Gamemaker to move the player. We're actually going to start manually checking ourselves to see if it's okay to move an object around. And this is sort of a big step into lots of games, especially if you're eventually thinking about doing a platformer. This will be a nice, easy introduction to it. So let's see what happens here. I have my up, down, left, right keys here, and the player moves, and it looks like it's all going well. And then a student tries to hug a corner, and you get this problem. You can see that I'm trying to move up, but the player is jammed on that corner because if you look right here, you can see the sprite is sort of touching and sort of not touching. And so it's sort of hard to get exactly dead. There we go. And so it's very difficult, right? So if you can get exactly in the spot, you're okay, but it's a bit annoying to do this kind of movement. So what we're going to look at is a way to fix this, and that's going to be our first little thing we do here, is fix this one up. So the problem's occurring, as you can see, because this sprite is not a square. This sprite, sort of detailed, and even though the head's passing the corner, then the arm gets stuck. So one thing you can do in grid games to avoid this is you can make the sprites act as if they're squares. And this is their collision mask. Okay, what counts as a collision? So we're going to fix that first. So when we go to the sprites here, you'll see by default, most sprites have this box ticked, precise collision checking. It's a little bit labor intensive for the computer. It's actually going pixel by pixel by pixel, checking for collisions. By turning this off and selecting to modify the mask yourself, I can just say use the full 32 by 32 square as the collision mask. Now, basically, yeah, if something hits right here, that'll be a collision instead of hitting there, but it's not a bad sacrifice to what you'll eventually see happen. And honestly, you don't even really notice too much with most sprites, especially 32 by 32 ones. So I actually am going to go and do that for every single sprite that I have, is turn off precise and just make it the full image. Grid games, we're going to make our units basically like a grid. And so full image, everything's going to be a 32 by 32 box in this game. Okay. So when I go to the room now, you can see, boom, 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 room. You can see here that I've set my snapping to 32 by 32 and the grid on. Everything is treated like a square. So as the player starts to move up, you can see his square, it's going to be always fitting beautifully into the grid. Now, does this solve the problem entirely? Not entirely. If I give this a run right now, I'm still going to get the player getting stuck a little bit. So I'm trying to move. There's still times when I want to move up, but I'm not exactly in line with the grid, and it's hard to get that square. Remember that 32 by 32 square there has to be exactly in line. So I'm going to fix that. We're going to do a little bit of manual movement. Now, before we do the manual movement, just let me sort of show you why by switching this grid to 1 by 1. Oh, maybe I have to do 2 by 2. Maybe I have to do 4 by 4. I'm trying. Oh, the smallest it'll let me do is 8 by 8. But if I pick up the player now and they're moving, and this would be the player moving 8 pixels at a time, you can see that what I want to have happen is I never want the player to end up there. For them to be able to move up nice and fluidly, they have to be right there, dead in the center of the intersection. And same thing when they get here. If they press left or right here, they're not going to move. They have to be exactly there. So one concept we're going to do here to make things simple for ourselves is, since I know the player starts out nicely aligned perfectly in the 32 by 32 grid, is I'm going to only move the player a number that divides nicely into 32. So I can move the player 1 pixel every time, 2 pixels every time. Don't move them 3 pixels every time, because you can see if I did some weird number, I'll just do a 9 here. If I move the player 9 every time, you do not end up lining up with the intersection nicely, and you'll never be able to move up. So what I'm going to do for my rule is I'm going to say always move the player 4. This is going to be the equivalent of Gamemaker having the player with a speed of 4. So it's really no difference. We're just going to do it manually. Let's go and actually do it. Whoops, sorry. So here we go. I'm going to go to the player, and I'm going to take out all my movement that I currently have. And we won't be using that anymore. Now what I'm going to do is I'm going to basically go into the step event. Now I'm going to be doing this manual movement idea that uses a method that you've seen before, which is place meeting, to check to see if I'll be colliding with walls. And I'm going to be using a new method here, which is a keyboard check. We may as well break into using actual keyboard detection ourselves instead of those events. So here we go. To check the keyboard, I'm just going to say if keyboard check, and as a parameter you pass it the name of a key, and I happen to know that the right key is VK right. The VK stands for virtual key. There's a list in the help file of Gamemaker. It'll tell you what all the keys are. If the keyboard check right, so this checks if the button is down, if that right arrow is down, so I'll say if true, then what I want to do is I want to know if I can move to the right. Now there's actually going to be another little check here. I don't want to move the player right away. What I want to do is I want to actually check if there's a wall there at the same time. So if VK right is true, and if the instance was placed 4 pixels to the right, would it be hitting a block? So that's my little double condition there. I'll just make this a little wider. If they're pressing right and 4 pixels to the right of me, whoops, I've made a mistake here. That should be false. I would not be hitting a block. That's a good place to move. And so if that's a free place to move, I'm going to move the player there. And here's the moving. X equals X plus 4. And that's it. And so when you do X equals X plus 4, it just picks up the player and moves them 4 pixels to the right. Now if you do the same idea for all the directions, so I'll have to do a little copy pasting here. Let's say VK left. I would be checking 4 pixels to the left of me if there's no wall. Then it is okay to move left. And then we do up. Up, don't be fooled here. When you're doing up, X is the same and Y is minus 4. Remember that it's opposite of your math class. Y at the top of the screen is 0. Y is really big at the bottom of the screen. So minus 4 is above. We would be moving Y equals Y minus 4. And this one will be moving down, Y plus 4. And this is X, Y plus 4. So remember what this place meeting does again, right? It picks up our player, puts him there, and sees would be touching a block. If it's false, we know that's a good place to move. There's no block. Now when we do this code, that's basically our manual keyboard check. I notice I'm only doing 1 line of code every time. So you know what? To make this a little shorter, I can take this out. And there we go. That's our 4 direction check without having to use the keyboard event. Okay, just use the keyboard check. Let's give this a go. And when you run this time, what you notice is the player still moves. If I'm pressing up right now, it's basically checking just above me, and the key's up, but there's a wall there, so it's not letting me move up. Now this movement ends up being great. You can hold 2 keys down at once. The motion is nice and fluid. Whoops, I've clicked out of the screen. And I notice my down is not working. I must have missed a variable there, but all the other directions are working okay. So let's just quickly go back and proof check that down direction. There we go. Didn't put that to down. I bet you probably caught that. So down, y plus 4, y plus 4. Perfect. Now, in the next video, what we're going to look at is we're going to look at the ghost movement, because the ghosts are a little bit different, right? They don't have the luxury of the keyboard telling them where to move. So what we're going to do with the ghosts is we're basically going to get them to move, detect intersections, and detect when they've hit a wall, and pick new directions using the concept from one of our previous lessons, which is lists. So it's a good tie-in with the list. So we'll see you in that video. Thanks for watching.